Hello everyone, in this video I'm going to explain the derivation of this equation minus mu1 by u plus mu2 by v equals to mu2 minus mu1 by r when refraction takes place from rarer medium to denser medium of a convex spherical refracting surface. And this is a spherical refracting surface, and this side is mu1, that is the absolute refractive index of the rarer medium, and mu2, this side is the absolute refractive index of the denser medium. Okay, before we start deriving, let us go back to some important points you should remember. The first one, exterior angles. In class 9 or class 8 you may learn about the exterior angles in a triangle. Here, let this be angle 1, angle 2, and this is angle 3. We can say that the exterior angle is equal to the sum of the two interior angles. Angle 1 plus angle 2 equals to angle 3. And suppose this is angle 3. Let us take here. Let us draw a straight line. This angle will be equal to angle 1 plus angle 3. The exterior angle, let it be 4. Angle 4 will be equal to angle 1 plus angle 3. We are going to apply this formula, and you should know that tan theta, for small angles, tan theta, if theta is very small, we can write tan theta is almost equal to theta. We can replace tan theta with theta, or we can replace theta with tan theta. Also, sine theta equals to theta. Okay, this is only for approximation. If you look at this table, you will find that the values of tan theta and theta, sine theta and theta for small angles are almost equal. They are almost same, but in this table the angles are measured in gradients, not in degree. Okay, and what else? Snell's law. As you learned in class 10, Snell's law tells us the refractive index of the denser medium. Suppose mu2 is the denser medium. With respect to refractive index of denser medium with respect to the rarer medium is equal to sine of angle of incidence divided by sine of angle of refraction. Mu2 1 is sine of angle of incidence by sine of angle of refraction. Here mu2 1 is the refractive index of the second medium with respect to the first medium. Here we consider that ray travels from medium 1 to medium 2. The second medium refracts the ray. The second medium will change the path. And also mu2 1 is equal to 1 by mu1 2. And we can also write mu2 1 as mu2 by mu1. Here mu2 is absolute refractive index of the denser medium, and mu1 is the absolute refractive index of the rarer medium. Then let us go to sign conventions. In sign conventions, all the distances are measured from the pole of the surface. This is the pole of the surface, and this surface is of small aperture. The width is very small. We consider the width is very small. Sign convention, everything is measured from the pole of the surface, and if we take incident ray along this, any distance which is measured in the directions opposite to the ray Here PO is opposite to incident ray. So it will be taken as negative. And if we measure it along the incident ray, like PC, okay, PC, it will be taken as positive. So we can say that any distance which are measured along the incident ray are taken as positive, and which taken against the incident ray are negative. And what else? Okay, assumptions. Here, the refracting surface, this is of small aperture, the width is small, and we consider that the object is a point object. The object is a point object, point sized, and it is situated at the principal axis. If we draw an incident ray, suppose this is the incident ray, and let this be the normal. The normal is any ray passing through the center of curvature. This will be angle of incidence, and here we consider it travels from rarer medium to denser medium, and it will be bent towards the normal. It bends towards the normal. So we have to draw like this. And this will be the image. And this is I, then this will be R, angle of refraction. In the assumptions, the incident ray and the refracted ray make small angles with the principal axis. So this is alpha, the angle subtended by the object, and this is the angle subtended by the refracted ray, that is the it will be beta, and this is gamma. We have to drop perpendicular. Let it be N, this A. Okay, PA. This is A, this point is A, and this is N. It is perpendicular. Here the distance of the object is PO, this is U, PO is U, and PC is R, and PI is the distance of image, that is V. This will be U, it is only in length, and this will be R. And this will be V, the distance of the object, the image. Okay. So let me start with Snell's law. According to Snell's law, we have μ2 1. The refractive index of the second medium with respect to the first medium is sin I by sin R, sine of angle of incidence by sine of angle of refraction. Here we take I and R are also small. Since this is very small, I and R will also be small. Alpha, beta, gamma are small, so I and R will also be small. So we can replace sin I with I. So it will be I by R. Okay. Sin I is nearly equal to I, and sin R is nearly equal to R. We can replace sin I with R and sin R with R. Okay. Then cross multiplying, we get, before that, μ2 1. μ2 1 is equal to μ2 by μ1. mu2 by mu1. So I by r, cross multiplying this equation, I into, we get I into mu1 equals to r into mu2. Cross multiplying, we get this. So we don't need this anymore. I mu1 equals to r mu2. Here we are going to calculate the value of I and r in terms of alpha, beta, gamma. Let us apply the exterior angle theorem. Here I is alpha plus gamma. If you look at this triangle AOC, these are the interior angles. Alpha and gamma are the interior angles, and I is the exterior angle. So I is alpha plus gamma. So you can replace I with alpha plus gamma. I is alpha plus gamma. So I is alpha plus gamma into mu1. Then R, what is R? How will you calculate in terms of alpha, beta, gamma? R is, okay, if you look at this triangle ACI, here, R and beta are the internal angles, interior angles, and gamma is the exterior angle. So R plus beta is gamma. R plus beta is gamma. Then R will be gamma minus beta. So R is gamma minus beta. Gamma minus beta. Mu2. So what is alpha? Again, let us apply approximation. Alpha will be replaced with alpha, beta, gamma. They will be replaced with their tangents. Since they are very small, alpha, beta, gamma are small angles. So alpha is nearly equal to its tan alpha, beta, tan beta, and gamma, tan gamma. Alpha is tan alpha, so they are not exactly equal. Alpha is replaced with tan alpha. Tan alpha plus tan gamma mu1 equals to, what is this? Tan gamma minus tan beta into mu2. Mu2. Can it be seen? Tan beta mu2. So tan gamma into mu1. Before that, let us apply the formula for tan alpha, beta, gamma. Here, tan alpha is perpendicular by base. It will be an by PO. Tan alpha is an by PO plus tan gamma is gamma an by NC. An by NC, or tan alpha it is NO, an by NO. Mu1 equals to tan gamma is an by NC, an by NC minus tan beta is tan beta an by NI, an by NI, and this is mu2. Here we can take an as common and cancel. They cancel each other, so we can get breaking the bracket, mu1 by NO plus mu1 by NC equals to mu2 by NC minus mu2 by NI. Here again we are going to apply approximation mu1 by NC. This is NC approximation again. These P and N are almost coincide, so we can replace N with P. It means NO is taken as PO, NC is taken as PC, NI is taken as PI. So all N will be replaced with P. Mu1 by PO plus mu1 by PC equals to mu2 by PC minus mu2 by PI. Here, or let us apply sign conventions. PO, what is PO? It is measured against the incident ray. PO will be taken as negative. It is U. PO is minus U, and PC, what is PC? PC is R, it is positive because it is taken along the incident ray, left to right. Then PI is positive, so it is plus V. Mu1 by PO is minus U plus mu1 by R equals to mu2 by R minus mu2 by V. Then we get this mu1 by R will go to this side, and this mu2 by V to the right side. Mu1 by minus mu1 by U plus mu2 by V equals to, then R is common, mu2, this will be minus, before that, mu2 by R minus mu1 by R. If we take R as common here, R, so it will be mu2 minus mu1 on the right side. Then this is the formula that we can derive.